Lithium batteries are basically everywhere in our homes these days, in all our electronics, our phones, everything we use. But more impressively, over 95% of EVs around the world right now are powered by lithium-ion batteries. Oh wow, that number alone shows just how dominant lithium still is as the gold standard in battery tech, with very few alternatives coming close to replacing it. But here's the thing. Lithium-ion batteries haven't really made any major breakthroughs in years. Their energy density hasn't gone up much, while the costs and fire risks haven't gone down either. That kinda explains why EVs still haven't fully won people over, partly because they're still expensive, and the safety concerns haven't exactly gone away. Even though Tesla has led the charge in lithium battery tech, and that's a big part of why the company is where it is today with lithium prices soaring, even Elon Musk has had to admit.
So the price of lithium and all the raw materials and the battery cells went crazy. It doubled. The price of cells doubled. Price of lithium, I think, went up at almost fivefold or 500%. Went up crazy numbers.
So it looks like lithium might not be Elon Musk's long-term bet after all. Because recently, word got out from Tesla's most secretive lab that something new has emerged. Something that could completely disrupt the lithium battery empire. Yeah, a totally new type of battery. This new battery uses materials that are way more abundant, and yet it delivers 3 times the energy density of lithium batteries. Now, we're not saying it's perfect. Every battery has at least one drawback, but across the board, this one completely outperforms lithium. And when that one last drawback is finally solved, this battery doesn't just compete with lithium, it destroys it. So what is this new battery? What makes it so appealing to Elon Musk? And just how powerful is it really? We've looked into it and we're about to reveal everything right now. As we mentioned, Tesla's current position is partly thanks to lithium batteries. The company has used LFP and NMC batteries for the Model 3 and Model Y, and the 4680 battery for the Cybertruck. All 3 types contain lithium, and even nickel and cobalt. If you search on Google or anywhere else, you'll see that these are very expensive materials, likely among the most costly components used in batteries. Even Elon Musk has admitted that the current 4680 battery is actually more expensive than other types because it contains all 3 materials, nickel, cobalt, and lithium.
Currently, our 4680s cost more than our suppliers.
It must be acknowledged that Tesla's 4680 battery is one of the best batteries available today. However, there's a bit of irony here because in our view, a great battery that's only used in an expensive car is somewhat disappointing. Right now, the 4680 is only being used in the Cybertruck, and even the cheapest version starts at $69,990. This has led many to question, with a sense of skepticism, whether Tesla will be able to use this battery in more mainstream models like the Model 3 and Model Y, at least at some point in the future. We're not so sure because lithium prices are still rising, and with such high costs, that seems almost impossible. Clearly, Tesla still relies heavily on lithium for most of its current battery types, and that's one of the main reasons the company hasn't been able to launch an affordable car. Although Elon Musk has mentioned plans to release a compact EV priced at around $25,000, that goal has been delayed for over 4 years. That's why recent leaks from Tesla's research and development division are drawing attention. Reportedly, the company is testing a new type of battery that doesn't use lithium. Yeah, a first-generation aluminum-ion battery, known by the familiar name A1 battery. Simply put, aluminum-ion batteries use aluminum ions as charge carriers instead of lithium ions, as found in lithium-ion batteries. An aluminum-ion battery consists of 3 main components. The anode, usually made of metallic aluminum, which supplies the aluminum ions. The cathode, made from materials like graphene, graphite, or metal oxide compounds, which stores the aluminum ions. And the electrolyte, a liquid solution that conducts aluminum ions between the anode and cathode. To make it even clearer, aluminum-ion batteries pack a bigger punch because each aluminum ion carries 3 positive charges, compared to just 1 for lithium ions. That means aluminum can shuttle 3 times the energy per ion, boosting energy density without relying on rare materials or fancy engineering. In theory, aluminum-ion batteries can store way more energy in the same amount of material compared to lithium-ion batteries. This explains why aluminum-ion batteries have a density that's about 3 times higher than most lithium-ion batteries today. Reports claim Tesla's aluminum-ion battery has hit over 700 watt-hours per kilogram in real-world tests. That's way crazier than we thought, because if you put a 700 watt-hour per kilogram battery into a Tesla or any similar electric vehicle, the range could easily top 700 miles, if not push toward 1,000 miles. How's that possible? Now, to put it simply, the current Tesla Model 3 long-range AWD has a range of 346 miles with a 79 kilowatt-hour NMC battery. The energy density of NMC batteries is around 180 to 200 watt-hours per kilogram. Now, compare that to aluminum-ion batteries, which have an energy density of 700 watt-hours per kilogram, about 3.5 times higher. If you swapped the Model 3 AWD's battery for an aluminum-ion one of the same size, the range could hit around 1,038 miles. However, we should note that while aluminum-ion batteries hit 700 watt-hours per kilogram at the cell level, the energy density drops a bit at the pack level due to components like the casing and cooling system. With a battery this energy dense, shrinking the pack size is key to cutting costs significantly. So instead of over 1,000 miles, a range of 767 miles is much more realistic. Despite being widely used, as we mentioned at the start of the video, lithium-ion batteries haven't seen any major breakthroughs in recent years, especially when it comes to energy density. Lithium-ion batteries have been stuck at an energy density of about 250 watt-hours per kilogram for decades, and even with Tesla's most aggressive improvements to the 4680 battery, they've only reached 272 watt-hours per kilogram. Of course, energy density isn't the only factor driving Tesla to pursue aluminum-ion battery technology. As Elon Musk has pointed out, a bigger issue lies in the skyrocketing cost of lithium batteries. The price of lithium batteries is rising mainly due to surging demand, while supply remains constrained. This clearly shows that lithium is being overexploited and is becoming increasingly scarce, driving up costs and putting manufacturers like Tesla in a tough spot.
Challenge on that front, then there may be a shortage of lithium.
When Elon Musk decides to invest in new battery technology, performance and energy density are always top priorities. However, what's crucial is that even a high-performance battery, if too expensive and only applicable to luxury vehicles, ultimately fails to have a broad impact. Therefore, aluminum-ion batteries must not only ensure performance, but also address the issue of production costs. Aluminum-ion batteries need to be significantly cheaper than the lithium-ion batteries Tesla currently uses. Otherwise, they won't help Tesla achieve its goal of bringing affordable EVs to the mass market. Of course, Tesla isn't a company that easily discloses pricing details, and to this day, they've never publicly revealed the actual cost of the batteries they use. However, it's still possible to estimate that the battery pack typically accounts for about 25 to 40% of the total production cost of a Tesla vehicle, depending on the battery type, variant, and specific configuration. For example, the Tesla Model Y, which ranges in price from $45,000 to $60,000 and uses batteries with capacities between 67 to 82 kilowatt hours, is estimated to have a battery pack cost between $9,300 to $11,400 based on an average NMC battery price of around $139 per kilowatt hour. This means the battery cost makes up about 19 to 25% of the vehicle's total price. Aluminum, on the other hand, is the most abundant metal in the Earth's crust, making up about 8.13% of its total weight. Bauxite, the ore used to produce aluminum, is widely distributed across dozens of countries. With a massive global reserve of up to 1.59 billion tons, aluminum is far more accessible and much less affected by geopolitical risks or supply chain disruptions. This gives Tesla a real opportunity to achieve ultra-low costs per aluminum-ion battery cell. Based on the information we've gathered, the cost of aluminum-ion batteries is expected to be significantly lower, with estimates ranging from $40 to $65 per kilowatt hour once the technology is fully developed. This cost could decrease further with large-scale production. In contrast, lithium battery production costs range from $80 to $145 per kilowatt hour, not including the expenses for costly materials like nickel or cobalt. To put it simply, If the battery for a Tesla Model Y currently costs between $9,300 and $11,400, switching to aluminum-ion batteries could reduce that cost to approximately $4,300 to $5,300. This change alone would significantly lower the overall production cost of a Model Y. Lithium prices have fluctuated sharply over the past 2 years, sometimes dropping but often spiking dramatically. As Elon Musk has pointed out, lithium prices have surged by as much as 500%. In 2024, the average price of lithium carbonate was about $8,200 per ton, and by February this year, it had risen to $9,271 per ton. This is due to global reserves of only about 89 million tons, nearly 18 times less abundant than aluminum. The situation is worsened by the geographic concentration of lithium. Most reserves are found in just 4 countries, with China holding about 16.5%, and the rest primarily in the lithium triangle of Chile, Bolivia, and Argentina. In short, aluminum is abundant and inexpensive, requiring no expensive materials. No lithium, no cobalt, no nickel. Just aluminum, graphite, and a suitable electrolyte. Meanwhile, lithium is becoming increasingly scarce, driving up costs. Aluminum-ion battery technology is ushering in a breakthrough in charging speed that lithium-ion batteries cannot match. While lithium batteries have achieved impressive advancements, allowing an 80% charge in 25 to 35 minutes, aluminum-ion batteries can fully charge in just 15 minutes without encountering temperature issues, a major drawback for lithium batteries. This capability stems from aluminum ions moving through the electrolyte 3 times faster than lithium ions, accelerating the charging process without compromising performance. Moreover, aluminum-ion batteries offer superior thermal management, effectively addressing the temperature issues that frequently complicate and reduce the lifespan of lithium batteries during charging. Thanks to this technology, aluminum-ion batteries not only enable faster charging, but also ensure greater safety and long-term durability. While lithium-ion batteries typically last around 2,000 charge cycles before dropping to 80% capacity, equivalent to about 3 to 5 years of daily use, some independent studies indicate that aluminum-ion batteries can achieve up to 15,000 cycles. This means aluminum-ion batteries could last up to 30 years if properly maintained. This is a significant improvement over current battery technologies, opening up promising prospects for longevity and durability. One reason aluminum-ion batteries can achieve such an extended lifespan is that aluminum is a highly durable material, widely used in modern car frames. Chemically, aluminum is also more stable than lithium. Unlike lithium, which readily reacts with oxygen and water, aluminum forms a natural oxide layer when exposed to the environment. This oxide layer acts as a protective barrier, preventing corrosion and degradation of the anode material, thus extending battery life. Additionally, the issue of dendrite formation, a major cause of performance degradation in lithium-ion batteries, is virtually non-existent in aluminum-ion batteries. Dendrites are metallic crystals that form during charging, damaging the battery's structure and causing serious issues like reduced performance or even fires. In aluminum-ion batteries, the release of aluminum ions is more uniform and stable, minimizing dendrite formation. Research from renowned institutions like Stanford also shows that aluminum batteries can endure tens of thousands of charge and discharge cycles without this issue, offering significantly longer lifespans than current lithium-ion batteries. Beyond lifespan, another serious issue with lithium-ion batteries is the risk of fire and explosion. Lithium batteries can ignite when impacted or overcharged, and the smoke from burning lithium is highly toxic and extremely difficult to extinguish. Despite years of development and improvements, safety advancements remain minimal. With aluminum-ion batteries, this fire and explosion risk is virtually eliminated due to their high stability and ability to withstand hazardous incidents during use. This is a critical factor making aluminum-ion batteries a safer and more sustainable choice for the future of EVs. Another significant advantage of aluminum-ion batteries is their high recyclability. Aluminum is one of the most abundant materials on Earth, and if aluminum-ion battery technology is widely adopted, it could address environmental challenges related to mining rare earth metals and recycling current batteries. Studies show that up to 80% of aluminum fluoride salts can be recovered in laboratory experiments, with projections suggesting even higher recovery rates at industrial scale. Moreover, solid aluminum foil can be easily reused after cleaning, making the design of aluminum-ion batteries highly conducive to recycling and environmentally friendly. However, while aluminum-ion batteries hold the potential to revolutionize the electric vehicle industry, not just for Tesla but for the entire sector, it's important to acknowledge that any new technology faces challenges and limitations. One significant issue with aluminum-ion batteries is their reduced performance in low temperatures, which limits their usability in harsh, cold climates. This is a critical factor that researchers are actively working to address to enhance the technology's practical applications. Aluminum-ion batteries have not been widely publicized, and they receive relatively little attention. However, based on these findings, if Tesla's A1 battery cells can be mass-produced and integrated into more affordable vehicle models, they could truly be a game-changer. Tesla plans to manufacture these batteries entirely in the United States at a newly expanded facility adjacent to Giga, Nevada. The production line is expected to begin operations by the end of this year, once all equipment is fully installed and calibrated. In theory, aluminum-ion batteries could last an exceptionally long time. Of course, no battery lasts forever, but the question is, how long can they endure? With a potential for 15,000 charge cycles, they are an ideal solution for energy storage, possibly lasting 30 years or more. And the cost? It appears highly competitive. Researchers suggest that mass-producing such a battery pack could cost the same or less than current LFP battery packs. Range anxiety remains a key concern for many EV consumers, especially for long-distance travel. A Tesla capable of traveling 700 miles on a single charge would completely eliminate this worry, offering unprecedented freedom and convenience. When Tesla achieves this range, it will not only produce an EV that rivals gas-powered cars in terms of range, but also position EVs as the primary choice for long-distance travel. If Tesla can address the low-temperature performance issue of aluminum-ion batteries, this technology could become a game-changing breakthrough, fundamentally transforming the electric vehicle industry. Currently, aluminum-ion batteries have demonstrated superior potential with rapid charging, long lifespan, and up to 80% recyclability, which reduces costs and benefits the environment. However, their poor performance in low temperatures remains a significant hurdle for widespread adoption, particularly in cold climates. Once this challenge is overcome, aluminum-ion batteries could not only give Tesla a competitive edge, but also become the cornerstone of its affordable EV strategy. Tesla might be the first to integrate these batteries into mass-market models like the Model 3 and Model Y, reshaping how consumers perceive EVs. What do you think about this? We hope this video got you hyped about the future of batteries and Tesla. If you're feeling the vibe, smash that like button and join the fam by subscribing. Don't forget to hit the bell so you never miss our epic content. Drop your thoughts in the comments. We love hearing from you. Thanks for tuning in, stay awesome, and we'll catch you in the next one.